Today we're going to be talking about product of the means equals the product of the extremes. Now really this is just adding on to proving similar triangles that we've already done. So this should be a relatively short lesson. So let's take a look at the example. So we have isosceles triangle RST with SR congruent to ST, and angle TER and angle SDT are right angles. They want me to prove that ER times SD equals TE times DT. So really, there's 3 steps when we do this. Step 1, we're going to prove triangle similar, which we already know how to do using angle. Then we're going to write our proportion. And then we're going to do product of the means equals product of the extremes. So let's take a look at what we would do here. So first of all, I have to figure out what triangles I'm going to be proving. So this is what I like to do. I like to take my highlighter, I say ER, and then I take another color, and I go SD. Then I have TE. So now you can kind of see that triangle right here. And I have DT. Right here, DT. So then you can see my triangle right here. So those are the 2 triangles I'm going to try to prove that are similar. So I have my statement and reason. I already write my givens. Alright, so that's all given. So again, if it helps us to redraw our triangles, we could do that. Alright, so first thing first, they tell me that okay, there we go. So they tell me that RST, which is the big triangle, is an isosceles triangle with SR congruent to ST. So I have SR, which is this, congruent to this. So that means that these 2 angles are going to be congruent to each other. Because we know that angles across from congruent sides are congruent. So if I say angle 1 is congruent to angle 2, because in an isosceles triangle, angles opposite congruent sides are congruent. Alright, so for step 3, we have another given that angle TER, which would be right here, and angle SDT is right here. They tell me they're right angles. So right there, we know that all right angles are congruent. So we can say angle TER is congruent to angle SDT because all right angles are congruent. All right, so now we did prove that triangle RET is similar to triangle SDT. And that was because of angle, angle. So that we already knew how to do, right? We did that lesson 2 days ago. So now comes in the lesson that we did yesterday, which was that in similar triangles, corresponding sides are in proportion. But we have to set up the proportion. They gave us this to prove. So what I do is I write out my proportion lines just like this. I say, okay, I know ER has to multiply to SD. Now, we're really cross multiplying. That's what product of the means equals product of the extremes means. So whatever you're multiplying needs to go across from each other. So then I have TE over DT. So if I was to cross multiply, those would multiply to each other, and that's what we have here. So the reason we know in similar triangles, corresponding sides are in proportion. And here comes the last part of the proof that is new for today. So the last part we prove is ER times SD equals TE times DT. And the reason is because this is number 6, in a proportion, the product of the means is equal to the product of the extremes. That's always going to be your reason for that. So now it's important to know that these 3 reasons always go in that order. So you're always going to prove triangles are similar by angle, angle. Then you're going to do your proportion. In similar triangles, corresponding sides are in proportion. And then you would do in a proportion, the product of the means is equal to the product of the extremes. So that's really just the lesson for today. So really all we did new was that we learned how to write out our proportion, and we just added on that last step, which was the proof. So before we go, I just want to talk about when you see something like this, when you have to prove this. When you see something like that, that is different than when you see something like this. This right here is the same as FB over FD equals FC over FE. So really you're just proving that in similar triangles, corresponding sides are in proportion. You're not putting on that last step because we're not multiplying anything. This is just another way to write a proportion. So just keep that in mind, that this right here is different than here, right here. Okay? So really, that's the only new thing for today. We're just adding on that product of the means is equal to the product of the extremes.